Hey everybody, hope you're doing well. We're going to talk about chapter 10 now, all about transactions. And here in section 10.1, we're going to look at what is a transaction and understand what the purpose of these are. And really, if you think about some of the examples that we've done so far, when we have all of these different tables that happen here, right? Maybe we had this product table over here, and one of the things product knew about itself was like our quantity, right? How many of these did we have? So we had product over here, and then we had a price probably over here. We had that, and then we had a customer table. And in here, we might have had balance, how much do they owe us as a field. Maybe we also had an invoice table, right, where we could log these, invoice. And then, because you want to sell many products many times, we have a many-to-many here. We can't do that logically, so what we need to do is have that joining table where you have like a line item, right, for a given invoice, and in that line item table then, right, we're going to have one product can be in many line items, and one invoice can have many line items, but one line item, right, will relate to one invoice and one product. So if you want to buy more than one thing in your invoice, right, you can add them all in here. So to do just a simple let's track that we sold something here, right? Customer ABC wants to buy products 1, 2, and 3, right? There's an amount of work that has to happen here. We need to add a new invoice, right? So we add a new row for invoice. We have to add a bunch of line items, right, for everything that they buy. We need to update the quantity from our product table, and then we need to increase the customer balance. Right? All of these different things have to happen in really, it's just one logical piece of work. So that's sort of what our transaction is. It's a logical unit of work that either it all happens or none of it happens. So if somewhere in the middle of this we have some sort of failure, we don't want to have charged the customer something but not logged the invoice, right? Or we don't want to have reduced our product in our quantity here, but not actually gone through and entered the invoice. So all of them have to happen in a, all or nothing. So the idea is that you want to be in a consistent database state, so that we're making sure that everything still matches, we have integrity everywhere, and that everything gets updated appropriately at the same time. So when we're looking at doing a transaction, right, that's the entire unit of work. Unit of work. That's all the work that has to go into that for us here. And we want to make sure that we can do the entire unit there. So all the inserts, all the updates, right, other inserts, and everything that has to happen here. And what we're going to do is we get to use this idea of starting a transaction. So in most languages, you'll say begin transaction. Begin, or most database servers. Now, we can't actually do this in the online tool, which is unfortunate. You can do it if you download their client and things like that, but that's probably more work than it's worth. So we're going to look at these, but we're not actually going to use any transactions ourselves. But that's okay. So you'll begin transaction, and then we'll do our update, right? We'll do our insert, we'll do our update, right? And then our other inserts, all these things that have to happen here. And then our keyword for finishing it here is commit. We say commit. Commit then is the point where it takes everything that's been done and does it in the database. So everything happens, it's being held essentially in some sort of a buffer in a transaction log where it's being stored, and then when we're ready to commit, we can apply that here. And there's a whole lot of really cool stuff we're going to talk about with concurrency and how databases manage things and make sure that they work here so that we don't get into really bad states. But for now, we're going to look at, here's the unit of work here. So we want to make sure that, excuse me, when we're done with our transaction, we commit it all, that it makes sure we get all of this one piece. So we can begin the transaction, do all of the work, and if anything fails, we can stop, or if we want to, we can roll back. So rollback will undo all of those things back to the state the database was in before we started that transaction, which is pretty cool. So we've got options. So it adds a little bit of overhead to this here. But the idea with our transactions is that they have this atomicity here. Atomicity. I can't spell, friends. I'm sorry. So all of our operations are completed or not, right? This is all or nothing. So we can either commit everything or we roll back and none of it happened here. We want consistency. But the idea with consistency is that we need to make sure we are in a good state. So when our transaction is done, we're in a consistent state. So we go from consistent state to consistent state. If we did part of our transaction where we like reduced the amount of product that we had available, we reduced the quantities, but we didn't actually add invoice line items for them, we'd be in an inconsistent state. So that's no good. Another piece about transactions here, these properties of transactions, is isolation. And the idea with isolation is that when we're doing something in a bunch of orders here, right? We do first transaction, second transaction, or not like first part of transaction, second part of transaction, third part of transaction here. We have to do them in order. So they have to happen, the first, then the second, then the third, then the fourth, right? If we're updating things and we do them out of order, our updates are going to be in bad states here. And this also has to happen in that our transactions, if two different people are trying to buy the same product at the same time, right? We have some beautiful website and everyone wants to buy our widgets, and we get two different customers trying to buy something. We need all of these updates to happen first before the next customer can go in and buy the thing and reduce the quantity even farther. So if you look at, say, excuse me, like if customer 1 wanted to buy 10 widgets and customer 2 wanted to buy 20 widgets, that's a 1 there, right? We're going to take the quantity minus 10 and then the quantity minus 20. Right? Well, if they both start at the same time and say our quantity was 30 here, right? We could get 30 minus 10 and 30 minus 20. We're going to get some bad numbers here, right? If they're not done in isolation. So that's a big deal, making sure this all happens. And we'll talk about concurrency as we go. We're not going to get super deep into it. It's a little bit more of an advanced topic, so we're going to touch on some of the sections here. You don't need to be worried too much about it because there's different ways the databases will go about it. You can go further into database administration and learn more about concurrency as well. And then the last property here of our transaction is durability. Means once it's done, durability, I-T-Y, I can't spell. English is not my strong suit. Means that once it's in, it's stuck, right? You can't undo it, or you can't lose it. Like to undo it, you could do the opposite. It's not really undoing. So it's protection even against failure. So it's going to stay there. It's stuck even if there's a failure. So if someone loses power and you're in the middle of a transaction, we're going to roll that transaction back. If it got committed, then we're going to get that state when we restore our database because it's been fully committed here. So that's the property of that. And there's also sort of this idea here. So you might hear this as ACID, this atomicity, consistency, isolation, and durability. It's known as ACID. Other properties we'll talk about are serializability, which is making sure that when we do our concurrent transactions, we get the same state, right? If we can have multiple transactions running concurrently versus them running one at a time serially here. So there's this looking at how serializable transactions are, right? If you're updating different sets of data, that's something you can do with it. So yeah, so those are the properties of a transaction. One of the things that database management systems do, this idea of this kind of a buffer of where it keeps all of these, is in the transaction log. Our transaction log. So this is another place where all of our transactions are being stored, and it's also used generally for failure and restoration in some sort of a bad event. So when we write our transactions, we write them to the transaction log. When we're done, we're able to commit them, change it in the actual data itself here. So in our log, we say we're starting our transaction, and then it logs everything that happens with the previous value, and the new value, right? So that's the before state and the after state, and then the commit finishes it. So the log is kept here so that if something happens, we can roll back. It just goes back to all these previous values. When we commit, it says, okay, keep all the new values. We're good to go here, which is really cool. So this adds to the durability of our transaction, right? Once it's been committed, it's in here. We've got it in the log. And then as well, we keep that transaction log generally as a separate file in case we need to restore our database. There's lots of cool things you can do with transaction logs and database backup and maintenance sort of things. So, all right, so that's the intro to what is a transaction. So we'll come back and talk more about concurrency and how that's going to affect our transactions in the next video.